Some background information that we need to know when working with fractions is firstly consecutive signs. Those can pop up in questions. So to remind ourselves of our consecutive signs, and you should definitely have this somewhere in your notes. If they are the same, your result will be positive. If they are different, your result will be negative. So we definitely need to know this in order to simplify some of our consecutive signs. We also need to remind ourselves on how to add and subtract integers. Which there is a video detailing how to do that. So if you're not so great with that, please go ahead and watch that video. But we need to know that so that we can add and subtract properly. We can just remember that if they are the same sign, we add and keep the sign. If they have different signs, we subtract and keep the sign of the larger number. We also need to know how to convert between mixed fractions. So we have to go both ways, from improper fractions to mixed fractions, and from mixed fractions to improper fractions. So let's convert. We will start with the example 2 and 1/4. The way we convert is by multiplying the denominator with the whole number and then adding the numerator. So 4 times 2 would be 8, and 8 plus 1 is 9. So this will be 9/4. So we multiply these. And then we add. Let's try a second example. Let's do 1 and 8/17. Again, we multiply these. And then we add that. So 17 times 1 is 17. Plus 8 is 25, and we keep that same denominator, 17. Our next example is 16 and 8/9. So again, we multiply. So 16 times 9 is 144, plus 8 is 152. The denominator is 9. So hopefully these are enough examples to help you convert from mixed fractions to improper fractions. The next thing we need to consider are similar fractions. So this is relatively simple because all you're doing is scaling your numbers up or down. So for example, if I have 1/2, if I wanted a different version of this number, I can simply pick a number to multiply the numerator and the denominator by. So say I want it to have a denominator of 8, I can multiply 2 times 4. but I also have to multiply the numerator so that I can maintain the value. So 1 times 4 is 4, and 2 times 4 is 8. And so I can scale up any fraction or create a similar fraction by multiplying or sometimes dividing by the same number in the denominator and the numerator. A second example of this is 2 over 3. And say I want to multiply the numerator by 5 and the denominator by 5 as well. If my aim is to get the denominator to be 15, I can multiply 3 times 5, but remember you also have to do it in the numerator. So 2 times 5 here is 10. You can also change whole numbers to have denominators. So say I want to choose the number 10. Every whole number can be written with a denominator of 1. So 10 is the same as 10 over 1. So if I wanted to make 10 have a denominator of, say, 8, I can multiply the denominator by 8, but remember we have to also do that to the numerator. So 10 times 8 would be 80, and 1 times 8 would be 8. And of course, if I divide these, it simplifies back to 10. So again, this is all the groundwork that we need when working with fractions. And so let's get into some examples. Now, fractions are like numbers with units. If I told you that I had a number, say 1 centimeters, and I wanted to add 4 centimeters, you would tell me that that's a total of 5 centimeters. Well, it sort of works the same way when we're dealing with fractions. If I have the number 1 with unit 10 plus 4 with unit 10, we simply add the top numbers, which is 1 plus 4 over 10, which is 5 over 10. So if you think of fractions as integers with units, it's a little less scary. Let's take another example. 3 over 8 plus 4 over 8. So we just add the top numbers, 3 plus 4, which is 7. And our unit, or denominator, is 8. And the similar thing works with subtracting. If I have 3 over 7 minus 5 over 7, 3 minus 5 is negative 2 with unit 7. If you have mixed fractions, it's essentially the same process. You just need to change those to improper fractions. So 3 over 4 minus 2 and 1 over 4 would be 3 over 4 minus, and we changed this before, it is 9 over 4. So 3 minus 9 is negative 6 over 4. Another example, 1 and 8 over 17 minus 12 over 17. Again, we already converted this to 25 over 17 minus 12 over 17, which is 13 over 17. And so once we have the same units or denominators, we can work with the top numbers or the numerators and keep our denominator just the same. Now, of course, it works a little bit differently if your units are different. You do not add 1 centimeter with 4 miles. Those two don't really go together. So you would have to change one to have the same unit as the other in order to add them or subtract them. So let's do an example of that. Let's do 2 over 5 plus 2 over 3. We can change both of these fractions and find similar fractions that will have the same units. Now, the denominator we'll try to achieve, we can find by multiplying 5 times 3, which is 15. So what we're going to try to do is to change 2 over 5 to have a denominator of 15, and also 2 over 3 to have a denominator of 15. We can do that by multiplying 5 times 3, which would give us 15, but remember we have to do the same thing to the numerator. We will also change this 3. We want to make it 15, so we have to multiply that by 5. So let's change this as well by multiplying it by 5. Our resulting fractions will be 2 times 3, which is 6, over 5 times 3, which is 15, plus 2 times 5, which is 10, over 3 times 5, which is 15. And so now they have the same units. We can go ahead and just add them. So 6 plus 10 is 16 over 15, and we're done. So the aim, again, is to make sure that they have the same units. That way we can add them or subtract them. So let's do another example of that. Let's do 4 over 5 minus 2 over 3. Now again, we have the same situation where one denominator is 5 and one is 3. So we'll change both denominators to 15 by multiplying by 3. And then we'll multiply this fraction by 5. 4 times 3 is 12, and 5 times 3 is 15, minus 2 times 5, which is 10, over 3 times 5, which is 15. Now 12 minus 10 is 2 over 15. Sometimes we can end up with different denominators and mixed fractions and whole numbers. So let's apply all that we've learned so far with those examples. Let's start with 16 and 8 over 9 minus 5 and 1 over 8. So before we changed 16 and 8 over 9 to 152 over 9. So we'll just use that. Minus, since we didn't change this one, let's do it together. 8 times 5 would be 40, plus 1 is 41 over 8. Now they do have different units or different denominators, so we will have to change them to be the same. Let us multiply 9 times 8, because then that will give us the denominator we're looking for, which is 72. So 8 times 9 is 72. So I will multiply this by 8, and then I'll multiply this by 9. That way the denominator will be 8 times 9 in both cases. We'll definitely need a calculator for this. So 152 times 8 is 1,216, and 8 times 9 is 72. Minus 41 times 9, which is 369 over 72. And from here, we simply just subtract these. So 1,216 minus 369 is 847 over 72. Another example with a whole number is 6 and 6 minus 3 over 7. Now remember that we can change our whole numbers to have a denominator of 1. So this is 6 over 1 minus 3 over 7. Now, since I can multiply 1 times 7 to have the same denominator as this fraction, I don't actually have to multiply both. I can just simply multiply this one. So 1 times 7 will get me to the same denominator as this fraction, and remember to do that to the numerator as well. 6 times 7 is 42 over 7 minus 3 over 7, which is 39 over 7. Next example, 2 plus 13 over 15. So again, 2 can be written as 2 over 1 plus 13 over 15. To get that to have a denominator of 15, we multiply it by 15, both numerator and denominator. So 30 over 15 plus 13 over 15 is 43 over 15. Now for the challenge question. Three and a half minus 4 plus negative 1 over 5. You can pause the video and try this one on your own. These are consecutive signs, so we have to clean that up. So we can rewrite the question as 3.5 minus 4, different, so resulting in a minus. Now let's change our mixed fractions. Two times 3 is 6, plus 1 is 7, so this will be 7 over 2. If I want to have the same denominator here, I need to write it as 4 over 1, so I can see how to get it to have a denominator of 2. Now, just like when working with multiple integers, when working with multiple fractions, it's best to take them 2 at a time. So we're going to work with these two. We'll multiply by 2 here, and multiply by 2 here. So 7 over 2 minus 4 times 2, which is 8, over 1 times 2, which is 2. Still write this because we'll come back to it later. We can subtract these. This is negative 1 over 2 minus 1 over 5. Now that we're done simplifying these two fractions, we will subtract the last two. I'll make myself some space. So negative 1 over 2 minus 1 over 5. To get them to have the same denominator, I'll multiply this fraction by 5 and then this fraction by 2. So times 5 would make 10 here. Do that at the top and the bottom. And then times 2 here would make 10. We do that at the top and bottom as well. This will be negative 5 over 10 minus 2 over 10. Negative 5 minus 2 is negative 7 over 10, and that is your final answer. So hopefully this gives you a full scope of what to expect when working with fractions.